Hello guys, how are you? Welcome back. From our previous video we had plotted the graph, so we have gone up to B. So now we are to calculate the gradient of this graph. Remember, how do we calculate the gradient? Gradient is equal to y1 minus y2 all over x1 minus x2. So to do that, we are going to have 2 points. We'll name another point 1 and another point 2. To get a mark for this, usually here we have, here it was 4 marks. This one could be 3 marks. This one 2 marks. This one is always a mark, right? So we have to have point 1 and point 2. To get the maximum marks here, we have to use a triangular method, and our triangle has to cover more than half of the line drawn, the line that we have drawn, right? You see, we have passed this point up to, if your line is drawn up to here, then you have to consider half of that line. So this is the line is from here to here. We are not considering points here, right? We just consider the line. We don't consider the plotted points. So I will choose this point here. I'll call it point 1. And here at the origin, I'll call it point 2. Right? Therefore, my triangular method will be from here. I should have chosen a different line, a different color for this. Let me do that quickly. Well, I've changed the color, so I'm going to show by this. This is how I show it. You have to do this so that your examiners see the points that you have used, right? So y1, what is the value of y1? That is the value of y at point 1. Where is point 1? Here is point 1. Where is the value of y? All the way through here. So this is 2.0 minus y2. What is the value of y at point 2? Here is point 2. What is the value of y? 0.0. And the units is centimeter, right? Divided by x1. What is the value of x at point 1? Here is point 1. What is the value of x? Vertically downwards, we get 6. So this is 6 minus x2. What is the value of x at point 2? Here is point 2. The value of x is this, 0. This is in Newton, right? So what do we get? We get 2 minus 0, 2, 6 minus 0, 6. This is 2 centimeter over 6 Newton. So this is 2 divided by 6. So this is what we get. G is equal to 0.3333 centimeter per Newton. So I have to write this correct to 2 or 3 significant figures. So correct to 2 significant figures, 0.33 0.33 centimeter per Newton. So having done this, I'll get all the 2 marks here. 2 marks. Get it? The units are correct, right? So now the next thing is to determine K, where K is 1 over G. So D K is equal to 1 over G. So what do we do? 1 over G. So the value for G, remember, we are not going to take the rounded value, we'll take this value instead. So this is 0.3333 centimeter. Let me do this. All over Newton. 1 Newton. It's 1 Newton. And I want us to notice here, we are dividing 1 by a fraction. We are dividing 1 by a fraction. So K is equal to 1 divided by 0.3333 centimeter all over n. So what do? We make this a multiplication sign. After doing that, the numerator becomes the one, the denominator. So this becomes n over 0.3333 centimeter. So if we get here, so we just a whole number can be divided by 1 to make it a fraction, right? It's allowed to remember in mathematics. We can always divide this by 1 to make it a fraction. It doesn't change the value. But what we are going to do here, we are going to have 1 Newton over 0.3333 centimeters, which is equivalent to, upon punching my calculator, this is what I found: 3.0003003 Newton per centimeter. The final answer can be written as K is equal to 3.0 Newton per centimeter. So having done this, you will get it correct. So another thing which is just a hint, guys, just a hint, right? If you have G is equal to 2 centimeter per Newton, and you are asked to calculate K, where K is equal to 1 over G, you just have to say 1 over 2, then you get what? 0.5. So the final answer is 0.5. The units here, they will just interchange. The one which was above will be below, right? You just exchange them like this. Simple. If you don't want to take the long route, which might confuse you sometimes. So that's it about this question of filling the blanks, plotting the graph, plotting the gradient, and determining K, where k is 1 over g. Okay, the next thing that we're going to do here is going to be looking at a few problems to do with proportionality of the force and extension. Oh, thank you.